Okay, we're going to be starting chapter 4-1, multiplication patterns with decimals. And in terms of these patterns, I'm really going to focus more on the procedures rather than conceptuals. So before we start, I want to review place value really quickly. Keep in mind that that's the decimal. Wherever you see the decimal, this will be the ones, tens, hundreds in the ones place. And again, we're going to be repeating like a ones, tens, hundreds, but in this time, this will be in the thousands place. And then again, we'll be having a ones, tens, hundreds, but this is in the millions. And so it'd be ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. And where you see the decimal, this is your tenths with the THS. This is your hundredths with a THS. And this is your thousands. Oops. Also ending with THS. And the reason why this is really important is when it comes to the answer and to look for the patterns. So as we learned in chapter 1, the numbers to the right are 1/10, and the numbers to the left of the number are 10 times as much as. And if you go 2 spaces, it's like 1/100th or 100 times as much as, or 1/100th, depending if you're going to the right or to the left. Then we're going to review that. I'm going to start by reviewing 1, 10, 100, and 1,000. And to do so, I'm going to multiply by each of those by a number to look for a pattern. Sorry, I had to go find my other pen. So we're going to multiply the number 3 and 72/100ths by each of those values. By 1, 3 and 72/100ths. By 10, 3 and 72/100ths times 100. And 3 and 72/100ths times 1,000. And in doing so, 1, you'll see the procedure of it, and 2, you'll be able to see certain patterns come up. Now, in terms of procedure, what you're going to look for is anything times 1 is still that number. So 3 and 72/100ths doesn't change. The decimal does not go to the right, it does not go to the left, because in doing so, you'll change the value. So here, where there's no 0, you're not going to move the decimal at all. And so your answer is 3 and 72/100ths. Because any number times 1 is the identity property of multiplication, it retains the same number and value. For the second one, we're multiplying by a power of 10. You have 1 0. So you're going to move the decimal 1 time. And since we're multiplying by a number larger than 1, the number is going to get bigger. So we're going to move the decimal to the right. So we're going to take this decimal right here and move it 1 time to the right. And so it should look a little like taking this decimal and moving it 1 place value. Now, a lot of students get a little tricked up by moving that decimal. You're moving it from one number in front of or behind the next one. So here, it's in front of the 7, it's going to go behind the 7. Okay, it's not going to go in between the 7, it's not going to go in between the 2, it's not going to jump 2 times, or it goes in between the 7 and then after the 2, after the 7 and after the 2. It's 1 jump. And what I do is I like to write it over here and visualize that's going to be 37.2, but I also rewrite it. And so when I rewrite it, I also go 3.72, and I take that decimal and I move it 1 time to the right. And this is where my new decimal is. So that decimal kind of quote-unquote disappears, and it's shifted and moved to another place value because we're changing the place value when we're multiplying. So our new answer is 37.2. So the first one was 3.72. The next one's 37.2. And the reason why I know that that's the number and how to say it is that this is my decimal, so this is the ones, the tens. So this is a 30, 37 decimal 2, 37 and 2 tenths. The next one, you could see that we have 2 zeros. So that means we're going to take this decimal and we're going to move it 2 times. Since we're multiplying, it's getting bigger since we're multiplying by a number larger than 1. So we're going to take the decimal and move it 2 times to the right. So it's in front of the 7. If we move it 1 time, it's behind the 7. If we move it a second time, it's behind the 2. And so our new decimal goes behind the 2. Again, I usually rewrite at the bottom, even though I kind of do a little cheat sheet on top. And the reason why, you'll see in the next problem. So if we have 372 decimal, this decimal means that this is the ones, tenths, hundred. See how I did that? Here's the decimal. It's the ones, tenths, hundreds. Ones, tenths, hundreds. So this number is actually 372. And when I rewrite it, I don't really need that decimal anymore because that decimal just means that it's ones, tenths, hundreds, 372. Here's the next one. You can see we have 1, 2, 3 zeros. So we're going to move the decimal 3 times because there are 3 zeros. And since we're multiplying, it's getting bigger by a number larger than 1. And so we're going to move it 1 time after the 7 because it's before the 7, 1 time after the 2, and then 1 more time because we have to move it 3 times. Now this is why I usually like to rewrite it, because over here it gets a little messy. So I'm going to rewrite it down here. Now I'm going to move it 1, 2, 3 times. Here's where the new decimal goes. Now you see where this blank space is. You're going to add a 0 here to show you that there's a place value here. And your answer is now 3720 decimal. Where the decimal is, to the left of it is the ones, tens, hundreds, thousands. So 1, 10, 100, 1,000, this answer is 3,720. And when I rewrite it, I'm going to add the comma to show the 2 different periods, the ones period and the thousands period. 3,720. Okay. Now I'm going to show you a different number, and this time with a power of 10. And so here you could see that we're just multiplying by ones, tens, hundreds, thousands. Keep in mind we could do the same thing using exponents. So the exponent for 1 looks like 10 to the 0, because it means that there's no zeros after the 1. Here's 10 to the first, which is equivalent to 10. 10 to the second is equivalent to 100. And 10 to the third is equivalent to 1,000. And this is how I remember it. I think of the number 1 as my base number, and there's 0 zeros after 1. Here's my 1, and there's 1 0 after 10, after the 1. Here's the 1, here's 2 zeros, here's the 1, here are 3 zeros. And just like here, the amount of zeros tells you how many times you're going to move it, you're going to do the same thing here with the exponent. And the exponent is the small number. This is called the base. So you're going to look at the exponent, and the exponent will tell you how many times to move the decimal. You will move it 0 times because the exponent is 0 and there's no zeros here. These are the same number, 1 and 10 to the 0. You move it 1 time because there's 1 0 and the exponent is 1. These two are the same number. You move it 2 times because there's 2 zeros. Here the exponent is 2. You move it 3 times because the exponent is 3 and there are 3 zeros. So let me give a different number now. Let's try 42.8, which is 42 and 8 tenths. And we're going to multiply it by 10 to the 0. 42 and 8 tenths. 10 to the first. 42 and 8 tenths. 10 to the second. 42 and 8 tenths. 10 to the third. And so we're going to be really looking at this exponent here to tell you how many times you're going to move it. And this exponent tells you you're not going to move it at all. So the 42 and 8 tenths will remain 42 and 8 tenths. Because 10 to the 0 is multiplying by 1, and it's the identity property of multiplication. For the next one, I'm going to put equal signs for all of these in black. You're going to move it. The exponent tells you 1 time. And since this number is larger than 1, we're going to move, and we're multiplying, we're moving it 1 time to the right. And so our final answer will be 42.8. Move it from before the 8 to after the 8. And it's 428 decimal. Keep in mind where the decimal is. It goes ones, tens, hundred, ones, 10, hundred. So this number is 428. Now let's try the next one. We're going to move it how many times? What does the exponent say? 2. So we're going to move it 2 times to the right because we're multiplying by a number larger than 1. So the number's getting bigger. And you can see here why I rewrite at the bottom. We move it 1 time behind the 8. We'll move it a second time and it gets a little messy here. So let's see what that looks like here. That's the first time. That's the second time your decimal goes here. Keep in mind what we did last time. We had an empty space. We put a place value there of 0. And so our final answer is 4280 decimal. And when we look for where the decimal is, it goes ones, tens, hundreds, thousands. Ones, tens, hundreds, thousands. So your answer is 4,280. And last but not least, we're going to move it 3 times to the right because we're multiplying, getting bigger by a number larger than 1. So we're going to go 1, 2, 3. And you can see here it gets a little messy, so I'm going to rewrite at the bottom. 42.8, moving it 1 time behind the 8, a second time, and a third time. You can see now I have 2 places where you need to substitute a place value of 0. And your final answer is 42800 and decimal. So if we go ones, tens, hundreds, thousands, 10,000s, you'll see it goes ones, tens, hundreds, thousands, 10,000s. So your answer is 42,800. And keep in mind you want to keep the commas to make sure that you're retaining the place, the different periods. Now, here are the 2 patterns that they kind of want you to look for when they say multiplication patterns with decimals. The first pattern they want you to notice is that the exponent tells you how many times you're going to be moving the decimal. So an exponent of 0, you're not going to move it. An exponent of 1, you're going to move it once. An exponent of 2 means you're going to move it twice. An exponent of 3 means you're going to move it 3 times. Likewise, the pattern for if there's no exponents, they're just the numbers, the amount of zeros tells you how many times you're going to move it. 0 times, 1 time, 2 times, 3 times. So that's the first pattern they want you to notice in terms of patterns with decimals. And the second is, if you're multiplying by 1, 10, 100,000, you could see the answer increase by 1 place value. Do you see how the decimal's just 3.72, 3 and 72 hundredths? And the next answer, when you multiply it by 1 power of 10, by 10, you'll see that the decimal shifts 1 time to the right. And so instead of it being 3, it's 37 and 2/10. When you multiply by 100, you moved it 1 more time, which is 372. And you can see when you move it, multiplied by 1,000, it moves just 1 more time. So you can see the decimal moving once, not all, 1 time, 2 times, and then you're adding a 0 there. Here's the pattern here. It is 42 and 8/10, then it became 428, then 4,280, and then 42,800. So that's kind of how to do multiplying by 1, 10, 100, 1,000, as well as 10 to the 0, 10 to the first, 10 to the second, 10 to the third. The second part that they want you to look at is how to multiply by tenths, hundredths, thousandths. And so this is where it gets a little trickier. So I'm going to turn this around. And this time, we're going to be multiplying by 1 over 10. I'm going to put that cheat sheet on top again. That's a comma. Sorry. So keep in mind that this is the decimal, so it's ones, tens, hundreds in the ones place, ones, tens, hundreds in the thousands. Thousands, no THS, sorry. It sounded like I said THS, and I think I might have. 1, tens, hundreds in the millions. And here's where you add the THS, the tenths, hundredths, because these are less than 1, they're apart, and the thousandths. Now, I'm going to show you how to do it with fractions, and it's going to be a very similar concept. So we're going to start with 1, and then 1/10, 1 100th, and 1 1,000th. And one thing I want you to notice from the one that we did before it is that there is that 1, 10, 100,000. There is that 1, 1, 10, 100,000, but this time it's a fraction. And so I'm going to give you a new number. Let's just choose a number. Let's do 378 and 6/10. And I'm going to multiply it by 1. Then we're going to take the 1/10, 1 100th, 1 1,000th. 378 and 6/10 times 1/10. 378 and 6/10 times 1 100th. And, ooh, I'm running out of room. 378 and 6/10 times 1 1,000. Now here, we're going to follow a similar pattern, but it's going to be slightly different. Now we know the identity property multiplication means if you multiply by 1, the number stays the same. So no decimals will be moving. The answer is 378 and 6/10, because when you multiply by 1. Now for 1/10, keep in mind this number is less than 1. So instead of moving to the right where the number is going to get bigger, we're going to move the decimal to the left. Because this number is less than 1, so you only have a part of something. It's a fraction, so you're going to have a fraction of the answer, a smaller portion of the answer. The second thing is you're only going to move it 1 time to the left, because there's 1 0. So if you take this decimal, and instead of it being behind the 8, you're going to move it 1 time to the left, you're going to move it 1 time this way, and in front of the 8, that is your new answer. So of course, I'm going to rewrite at the bottom, 378.6, move it 1 time to the left, means it's going to go in between the 7 and the 8. And so our answer is going to be 37.86. Okay, and that number is decimal, ones, tens, 37 and 86 hundredths. So here it was 378 and 6/10, and now you moved it 1 time to the left, 37 and 86 hundredths. This time we're going to move it 2 times because there's 2 zeros. And again, we're going to move it to the left this time instead of to the right because it's less than 1. So it's a fraction, it's a part of the answer. So we're going to take and go 1, 2. Or in other words, we're going to rewrite it. And we're going to go 1, 2. So you could see it's between the 3 and the 7. 3.786 means this is the ones, 3 and 786 thousandths. And last but not least, we're going to move it 1, 2, 3 times, and this time it's going to go to the left instead of to the right because this number is less than 1. 1, 2, 3 means it's in front of the 3. And if I were to rewrite it, 378.6. 1, 2, 3 means it goes in front of the 3. So this final answer is decimal 3786. Now in front of the decimal, this is the tenths, hundredths, thousandths, 10,000ths, even though we didn't learn the 10,000ths yet. You could put a 0 in front if you like, and it will not change the answer. Because keep in mind, in front of the decimal is the ones place. There's nothing in the ones. So you could either leave the answer as a decimal 3786, or you could add the 0 there. They're both the same. They're both equivalent. And that's how to do it. It's very similar to the one we did in front, but instead of moving to the right, because these are ones, tens, hundreds, thousands, this is more than 1, we're moving to the left. 0 times, 1 time, 2 times, 3 times, because it's less than 1. Last but not least, we have to think about how else we could write the fractions and in decimal, which means in decimal form. So 1 we're going to keep as 1. This is 1/10. 1/10 is over here. So if you're to put 0.1, this is the ones, that's the tenths. These two are equivalent. For the next one, for the hundredths, you'll have 0 decimal, nothing in the tenths, 1 in the hundredths. These two are the same. And last but not least, in the thousandths, so you could see here, this is 1, this is 1/10, 1 100th, 1 1,000th. So if you were to multiply the numbers by 1, by 1/10, by 1 100th, by 1 1,000th, it will go the same. These are equivalent. You'll do the same exact process. And so this will be our last example before moving on to the homework. And this time I'll put the problem as 37.9, which is very similar to that, my bad. So we're going to multiply it by 1. 37 9/10, we're going to multiply by 1/10. 37 9/10, we're going to multiply by 1 100th. And 37 9/10, we're going to multiply by 1 1,000th. Now this is what I usually do. Oops, I forgot the equal sign. That's my cheat sheet. Keep in mind when you multiply by 1, it's the same number, 37 9/10. Now here, instead of looking at it as a decimal, I'm going to change it to a fraction. So this fraction means it's in the ones, tenths. This is 1/10. And when I change it to 1/10, it's easier to look at it like this, where I know I'm going to move it to the left because the number is less than 1. And so the number is getting smaller, it's a part of something. And second of all, I'm moving it once. So I'm taking this decimal, and because there's only 1 0, moving it 1 time to the left. And so it becomes 3.79. 3.79 means 3 79/100ths. So it went from 37 to 3. 37 9/10 to 3 79/100ths. Then we're going to do the same thing for here. Instead of looking at this as 1 100th as a decimal, I'm going to change it to a fraction. Keep in mind, I know that this is the fraction because here's the decimal, that's the tenths, the hundredths, 1 100th. Which means I'm going to move it to the left 2 times, 1, 2. And so I'm going to take this decimal, and I'm going to move it 1, 2. And so it goes in front of the 3. Decimal 379 means 379 thousandths. And keep in mind, because there's nothing in the ones place, I can put a 0 here, and it stays the same value. I could write it either way. They're both equivalent. And last but not least, I'm going to change this. This is the number tenths, hundredths, thousandths, 1 over 1,000. I'm going to move it to the left 3 times. 1, 2, 3. And so here, you're gonna realize I'm gonna have to add a 0, just like I did in the past ones where I had to add zeros. Okay, so let me rewrite that at the bottom. 37.9, and I'm moving it once in front of the 7, once in front of the 3, and one more time where I'm gonna have to add a 0. So my answer is decimal 0379, which means 379 10,000ths. Keep in mind, in front of the decimal, there's nothing in the ones place, so I can add a 0 here. But it will be wrong if it's decimal 00379. Keep in mind, it has to be decimal 0379. You're looking at where the decimal begins, because that tells you where the ones place is, the tenths, hundredths, thousandths, and 10,000ths. That being said, I think you're more than ready if you're really seeing these patterns here. The main difference is with the first numbers, if it's larger than 1 and you're multiplying, then you're moving to the right. If the numbers are less than 1, you're going to move to the left if you're multiplying. And then the zeros tell you how many times you move it, or the exponent tells you how many times to move it. So I hope that this video helps. I am going to do a couple of problems here, but not too many. If I do... Oh, another thing I want you to notice is most of the problems I wrote look very similar to this first column, where the ones, tenths, hundredths, thousandths, the one, the tenths, the hundredths, they are to the right side. If they're to the left, think about it as the commutative property. You do the same thing, you just flip it over. So instead of looking at it here, you're looking at the right side. Move it 0 times, move it 1 time, 2 times, 3 times. I'm going to choose two that I think are the most complicated, which for me feels like 4 and one where it's a little tricky. Let's do one of these ones. Let's do number 5. So I'm going to do numbers 4 and 5 with you. 390 times 1, anything times 1 is the same number, the identity property. So it's 390. You do not move it at all because there's no zeros, there's no exponent. Instead of looking at this as a decimal, I'm going to change it to a fraction. Here's the ones, decimal, tenths. So this is 1 over 10. Because it's less than 1, I'm going to move it to the left, and I'm going to move it to the left 1 time because there's 1 0. So there's the number 390. And if you wonder where the decimal is, Miss Tolentino, there is no decimal. Well, keep in mind our cheat sheet. Here's the 3 is in the hundreds place. The 9 is in the tens. The 1s is in the 0s in the 1s. That means there's a decimal here, even if you're not writing it in. Now you can move it. So at the end of 390, the decimal's at the end because this is the 1s, and the decimal's at the end of the 1s. And you're going to move it 1 time to the left. And so instead of it being behind the 0, it's going to be in front of the 0. And your answer is 39.0. 39.0 would look like this. 39.0, which would mean it'll look like 9s, 10s, 39. So you could put 39.0, or you could put 39. These are both the same answer. I prefer 39 because it shows a stronger sense of number sense, that you realize that 39.0 is 39. So I would prefer 39. And then here, I'm going to change it. So here's the ones, tenths, hundredths. So this is 1 over 100. And we're going to move it to the left because it's less than 1 that we're multiplying by, so it's a part of something. And we're going to move it 2 times because there's 2 zeros. So if we take 390 and we move it 2 times to the left, you know that the decimal is at the end of the ones. We're going to move it in front of the 0, in front of the 9, and that's where it's going to end. 3.90. 3.90 means 3 and 90 hundredths, and it's also equivalent to 3 and 9 tenths. And I prefer if you have both answers because that really shows me that you understand that if there's nothing in the hundredths place, it's equal to 3 and 90 hundredths, or you could even omit that. Whew. Last but not least, I'll do number 5, and then I'll help you set up equations for numbers 10 and 11. Here, even though it's on the left side, this is telling you what to do instead of it being on the right side. Think about the multiplication, the commutative property multiplication. You could flip it, you could swap it, and still the same answer. In terms of the 2 factors, it'll give you the same product. So here, since the tenths are over here, it's telling you do not move the 0. Keep in mind that 10 to the 0 is the same as 1. So this is the same answer, 49 and 32 hundredths. It says do not move the decimal at all because the exponent is 0. Don't do anything. Plus 10 to the 0 is equivalent to 1, so it's identity property multiplication, just in a different look. 10 to the first means you're going to move it 1 time, and this is larger than 1, so we're going to move it 1 time to the right. So take this decimal and move it 1 time to the right, and your decimal is now in between the 3 and the 2. So it's 493.2. I do want you to rewrite this. You may need a separate piece of paper for it. I'm going to try to fit it and squeeze it in here. For this one, you're going to move it 2 times to the right because the number is larger than 1, and the exponent says 2. 1, 2. If I were to rewrite it, it goes behind the 3 once, behind the 2 the second time. And when the decimal's at the end, that's saying it's the ones, tenths, hundredths, thousands. So this is 4,932. Because if the decimal's here, ones, tenths, hundreds, thousands. Then we're going to move it 3 times to the right. 1, 2, 3. And this is why I want you to rewrite it, because this looks messy. So definitely rewrite it. If you have enough space, do it in the book. If not, get a separate piece of paper. Behind the 3 once, behind the 2 second time, behind the 1 extra spot. You're going to add a 0 here. And if that's the decimal, this is the ones, tenths, hundreds, thousands, 10,000s, 49,320. Ones, tenths, hundreds, thousands, 10,000s. So keep in mind the patterns. You're looking for 2 types of patterns. The patterns in terms of what to do with the zeros or the exponents, as well as how the numbers are shifting. For 10 and 11, you're going to be creating equations that look like this and oftentimes solving for it. So Nathan plants equal-sized squares of sod in his front yard. So he's planting and gardening. Each square has an area of 6 square feet. Nathan plants a total of 1,000 squares in his yard. What is the total area of squares what is the total area of the squares of sod? So what he's saying is 1 square is 6 square feet. And that's 1 square. The second square is 6 square feet. Oops, I need a small square feet there. And we're going to have 1,000 of these. 6 square feet. And so what you could do is do 6 plus 6 plus 6 plus 6 1,000 times. Or a faster way to multiply is 6 times 1,000. And we know 6 times 1,000 because it looks very similar to these patterns. So now that I gave you the equation, you could go ahead and solve it. Don't forget you need the picture boxes. This is X is the total area of square sods. For number 11, 3 friends are selling items at a bake sale. May makes $23 and $25 selling bread. Inez sells gift baskets and makes 100 times as much as May. Carolyn sells pies and makes 1/10 of the money Inez makes. How much money does each friend make? Ooh, this is a cool one. I like this one a lot. Okay, I'm going to do the boxes up here. We know that May makes $23.25. That's how much money she makes. Inez sells gift baskets and makes 100 times as much as May. So whatever May made, which was $23.25, she made 100 times as much. So she made 100 times as much. So what Inez did was, Inez is 23.25 times 100 times as much. Because keep in mind, you could do 23.25 plus 23.25 100 times, or just multiply it out. Inez makes 100 times as much as whatever May made. 100 times is May's amount. Last person is Carolyn. And she makes 1/10 the money of Inez. So you have to find what Inez makes. And she makes 1/10 of that. So first you need to solve Inez. So to solve Inez, you need to multiply it 2 times to the right. 1, 2. And you find out that Inez is 2,325. Because you found that out, Carolyn makes 1/10 of that. So you have to take the 2,325 and divide it by or not divide, and multiply it by 1/10. So that's kind of cool. That's kind of tricky. I know I went through this a little bit quickly. Slow it down, rewatch this one a little bit, but I want you to try to do number 11 on your own. I gave you a couple of hints, but hopefully I didn't spoil it for you so that you could think a little bit critically on your own. Don't forget to show your work and do the back side, and hopefully those helped you. All right, have a good day.